Hello. So in this video I will show you several things. The first thing is how to set up a thresholder to quickly draw an annotation of an entire region from a tissue slice like this. And then I will also show you how to do some multiplexed analysis to count cells which will be double or triple positives. And maybe I will also show you some scripting, some very light scripting, how to automate a bit these things to get a bit faster if you have many images to process. So the first thing to do here, if you want to use a thresholder to create an annotation, is, since this is a fluorescence image and a multi-channel image, is to select the right channel to do that. So if you have a look here, I would like to use a channel where I have a good signal in the background. So maybe this one, this orange one, is okay. Yeah. And if you look at the lower right of your screen, you will see the intensity here under the cursor. So if you have just one channel enabled like I do here, the value that is displayed is the current gray level corresponding to the channel. So if you want to be a bit thorough, and when you do the thresholder, you have to make sure you set up the right value. So for instance here it should be, let's say, something about 500, let's say, as a minimum, something like this. We can try it, but this gives you an idea, and this works for the orange channel. So let's use this as a basis, and we can go now to classify, pixel classification, and create thresholder. Yeah. So one thing you have to do is to set up what kind of class you will affect to the pixels that are above the threshold. So here I have the default classes, which you can see here in this list. So I will probably just use region here, so it's in blue. And now, since I haven't set up any threshold, everything is staying here. So let's use our 500 value. And so maybe this was a bit too high, so let's try half of this. Okay, so this seems to work, but as you can see, we have several holes inside our region. So to remove that, there are several ways. Here you can change the smoothing sigma factor, so let's use 5 for instance, and you can see it automatically fills the holes and gives you a more roundish region. It's smoothed out. This is also depending on the resolution where you work at. If you work like that, it's useful to work at low resolution, because if you want to have a more precise cutout, you can go with a higher resolution, but then you will get back those holes, which you can fill later on if you want to. But in this case, let's just use a low resolution, because this will work for us. So once you're satisfied with this, you can give your thresholder a name. So since it's sorry, it's not with the right, that's why it wasn't working. Just check here. Yeah, 500 was still too high, but let's go back here. It should work. I wanted to work with the AF 555, so let's use this as a name, AF 555 thresholder. like that, and save. So now my thresholder is saved, and I can create objects or do a classification or a measurement. I just want to create objects here based on the full image, and what I want to create is an annotation, and here I can filter out small objects, so I can input that also if I want to. Split objects if there are some connections. So in this tissue slice, it's okay. You probably won't have any issues with several blobs around the main part, but I would suggest for the sake of automation later on to make this, because it will save us a step later on. And you can press OK, and then you can close this window. And now we have a nice cutout of our region here. So if we go to workflow, we can see pixel classifier, create annotation, reset selection, etc. So those are the steps that are repeatable and that can be recorded somehow. But if we want to really build a script, we have actually to start from scratch. So what I would do here, for instance, if I wanted to automatically have a script to do that, I would just get rid of this region here, and then the step is actually to go to classify, pixel classification, load pixel classifier. Here I choose my thresholder, create object, OK, and OK, and then close this. And now in my workflow I have pixel classifier, create annotation. So this is the step I can use for automation. So if I want to, I can create a workflow here, and I just don't need any of the other steps here. So I just shift click and select them and remove selected items. Yep. And then I can create a script with just this. So I will just save this script as thresholder. Let's call it step 1. Okay. So let's just try it. Now if we go to automate project script, we have step 1 thresholder. It opens up our script, we press run, and we have our region automatically. So this is now quite quick to do. So at this point you can edit your region, and for this I would probably just, let me just see, where is it, show, no, it's not that, sorry, show input display. Here I would just put this because it allows you to see the commands I'm using, so it's a bit easier for you to follow. So if I want to edit this region here, when it was created, actually it's locked. So if you want to edit it, you have to unlock it here, and then you can use like the brush tool here, for instance, to cut through the region and separate it into multiple other regions. So because, let me just enable the green channel, for instance. You can see that in this tissue you have several regions where you have different cell types. So if you want to isolate here this part, you can cut here and here, something like this. So I make sure my region is unlocked, and Since the brush works, let me just see here, like this, the size of the brush depends on the size of the zoom level. So if we want to be consistent, we have to set up the same magnification everywhere. So let's use 5 for instance, and here I will use the shortcut M to move my view like this. Here I make sure to select the tissue, I have the brush selected, and I use the Alt key, and if I draw here, I'm now cutting, so you can see I've cut a part here. So let's do the same here. Again, let's just choose 5. Okay. Sorry. Just to recenter a bit. It's not that easy. You can also use the minimap here to move a bit like this. Okay. Here and Alt, and we drew like this. Where should I go? Here. So this is just a rough estimation of how to edit this region, something like this. So this is quick and dirty, but you get the idea. And now this is still just one region, and I just moved it so I put it back in place. Sorry for that. And then you have to right click, edit single, and split. So now you have 2 objects, and so here you can measure that with another method if you want to, and here you can get some information like the area or something like this, which would be of interest for you, for instance. So here I just want to now do some other kind of work, like let's say cell detection, and see if I enable again all my channels like this. Yeah, you can see that we have cells with many colors here. Some have green, some are orange, etc. So if you want to check which cells are double or triple positive or single positive for each of the markers, you have actually to train object classifiers. So in order to do that, I will now switch to another image and do this properly. I could work from here, but I want to show you how you want to work properly with that. So here I will change this. I can save here for the moment. And what you want to do here is take one image, one copy of this image for each of the channels, and create a thresholder in each of the and create a classifier for each of the channels. So let's do that. You go to classify training image and create duplicate channel training image for all the channels that you want to train. So we don't need the DAPI here. I create OK, and now you can see I have copies here for each of the channels. So let's start with the first one. So now I'm on this image here, and what I will do is just enable the channel I'm currently working on, so the green one. I want to create just a small region like this to go a bit fast. Let me just also enable the DAPI just for the sake of counting the cells. And now what we need are actually detections, so cells, And to do that, you go to Analyze, Cell Detection, and Cell Detection again. Here. So here you can create cells based on any channel you want and all the characteristics here. So I won't go into the details here. I will just leave the default values because for this image, I know that they work quite well. So let's just run it here. And let's see. Yeah. So we have detected the cells here. This works quite well. And now that we have some detections, you can fine-tune this, of course. Just decrease a bit the opacity so that I can see it a bit better. What I want to do is create some annotations for each, for cells that are positive in green and the rest. So that means I need to have classes corresponding to my channels, so I can add those classes here by using the command populate from image channels. And I want to keep the existing classes, yes. So now I have classes for all the channels. So I will set into green regions that are actually having green staining. And I will auto set this just to be a bit quicker. So let's just paint some regions like here where I can see green signal. So let me just remove here this for a moment. So green here, green, green, green. Okay. And now let's put ignore as a class for everything else. So I can put ignore here where there is nothing, ignore here where the signal is too weak. Where should I put ignore? Maybe here, something like this. And now we have several ignore regions and several green regions, or AF488 regions. So now I can train my classifier. So I can go to classify, object classification, and train object classifier. I can make sure I want to use only selected classes here, but in this case there are only two, AF488 and ignore, so this is very simple. You can just use this. So if I press live update, I should see now some cells are green, some are red, meaning that they are not positive to AF488. Here I think it's still a bit too harsh, so let's add a more ignore region like here. And now the ratio is a bit better. Let's see. Yeah, I think it's fine like this. So let's save it here. So I will call this AF488 cell classifier and save it. Let's do the same for the other channels. By the way, while I'm here, the step cell detection here can be used also for scripting. So this is quite nice because all the parameters for the cell detection are saved here. But if I switch to another image, it will be lost. So let's just use this, since I want to repeat this, and create a script based on that. So create workflow. I don't need that. Yep, and create script. And save this script as step 2. Cell detection. Like this. Okay. So let's go to the other channel. Save the changes here. Yeah, we can see it. Now this one is the orange channel, and let's do the same as we just did before. And here select a region, and since I have cell detection, I can use this here to use exactly the same parameter to create the cell detection. Here annotation, we already have the right classes, so let's use this. And again, I just want to see the orange. Okay, and draw some orange regions. Here, this is positive in orange. Here, and yeah, maybe already drawn that. Maybe here. Okay, and let's add some ignore region here, 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 and here. And let's train our classifier. I can choose live update. So yeah, it's probably difficult to see. If I fill the detection, it will be probably easier for you to see. So that looks okay to me. So let's save this as AF 5, so classifier, and save this. So let's quickly do the last channel. So same thing. Like this. Use our cell detection. And we create some annotations. So here, here, so there are fewer cells here. Now ignore this. Let's have a look on how it looks like. Probably too many positives here. I don't know. Yeah, well, it's difficult to say, but let's say this is okay. I just want to go quickly here. So AF 647, so classifier, and save it. So now I've created several classifiers here, and if I go back to my original region here, original image, let's save this here. Was it this one or was it the other one? No, it was this one. Let me enable all the channels like this. Here now I can use cell detection in this region. So let's run it. Okay, so it's a large region. And now we can also classify all those cells. And to do that, we have to build a compound classifier. So a composite classifier. We can go to classify, object classification, and create composite classifier here. And here we can load up all our classes here and save this as composite classifier. Save and apply. And now if we have a look at this annotation here, just move this here quickly, you can see here all the detections, so 13,000, and here you can see all the different classes. So we have subclasses also, which is quite nice. So if I just remove quickly all the channels so that you can see a bit better, it will look like this. So it's a nice rainbow of colors. That's because we have also double and triple positives that are stained with a mix of the colors. So, if this is not really easy for you to read, what you can do here is just populate from existing objects to add also the subclasses. Yes, I want to keep everything. So I now have the subclasses, so the classes for the double and triple positive, so we can see those two colors are pretty close to each other. So if I want to have the triple positives, for instance, with a separate color, I can just double click here and put a bright yellow, so it's easier to identify them, for instance. Yeah. So this is quite nice to be able to have this multiplex analysis. And if you want to automate this step, the only thing you have to do is to go to classify, object classification, load object classifier, and we have the composite classifier here, and press apply. So here it has already been done, but what you can do here now inside the workflow is have this step here that is recorded here and use it to create a script, or maybe combine it with the cell detection, so you can do everything in one go. So let's again do this. So just remove everything else. So I can save this as a separate step if I want to, or have a step which combines cell detection. So let's do both. So save as step 3, classify cells. So it's just one command, but it's easier to do. And what I can do also is just copy this, paste this here, and now save this as another step, step 4, cell detection and classification, and save it. So for instance now, let me just so quickly go here and just define a region, I don't know, somewhere here, and I can go to automate and oh, where is my script? Interesting. Just open the script directory. Did I overwrite it? Perhaps. Let's just see what I did. Sorry. No, it's here. Strange. Maybe it just didn't update properly. I should have 4 files. It's because it wasn't in the right folder. Anyway, you can run it here. It should be put in the same folder as the other ones. So I can run this, so it will do automatically do cell detection and classification in one go. Yeah, maybe I should have drawn a smaller region. And here we go. So here you can see there is a large difference in the balance of the different cells. And if you just want to know which one are which, you can double click here and see that this one belongs to this double positive class. So here you have a cluster of cells with double positive. So here you go. This is the end for this tutorial. If you have questions, just email me, leave a comment, or ask in any kind of ways you think of. I will be happy to answer. Thank you for listening. Bye bye.